Walter is currently in space gathering data, and we're going to use this data to gain an understanding of standard form, which is a method of formatting large and small numbers in a more simplistic and manageable way. And then in a follow-up, we will look at the second way standard form is useful, which is to perform calculations. So to leave a number in standard form, which is also sometimes called scientific notation, we have two rules that we must follow. So the first rule is that we need a number that's between 1 and 10, and it can be a decimal, and quite commonly is. And the second rule is that then we're going to have 10 multiplied to a power. So to start with a simple example, and we usually would look at numbers that are much, much larger than this, let's start with 123,000, and we're going to find our number between 1 and 10. And we do this by shifting our decimal point from the end of our number until it's in the right position so that we have a number that's between 1 and 10. So if we move our decimal place 5 spots to the left, we now have the number 1.23, and that is a number between 1 and 10. So that satisfies our first rule. And because we moved it 5 places, we now know the power that we raised 10 to, and that satisfies our second rule. So 123,000 in standard form is 1.23 times 10 to the 5. The first measurement that Walter has taken is of the diameter of the Earth, and in kilometers that's 12,742. So if we convert this to standard form, we shift our decimal place from the end of our number 4 times so that we end up with 1.2742. So we know that our decimal is 1.2742, and we shifted it 4 places, so we know that the other number that we're finding is a 4. So 1.2742 times 10 to the 4. If we look at the Earth's diameter in meters instead to give us a larger number to work with, in meters the Earth's diameter is 12,742,000. To convert this to standard form, we have to move our decimal place 7 places instead. So now we have 1.2742 times 10 to the 7 to give our diameter in meters. Our spaceship is 4.35 times 10 to the 7 centimeters above the Earth's surface. We're going to use this measurement to convert from standard form instead. Looking at our power, 7, is a positive number, which means that we're going to have a big number and that we need to move our decimal point toward the 7, so to the right when we are dealing with positive integers. Shifting our decimal to the right 7 times, this leaves us with 43,500,000, so 43,500,000 centimeters. Let's leave Walter to go back to data collection, and instead we're going to talk about Space Lab. These are some measurements from a recent experiment on stem cells. 9.8 times 10 to the minus 5 and 7.8 times 10 to the minus 7. So the first thing that we notice is that our integers this time are negative, which means we're going to be dealing with small numbers. And when dealing with small numbers and working with negative indices, we need to shift our decimal point to the left to give us a decimal number instead. So doing that 5 times in our first example gives us our first answer. And then 7 times in our second example gives us our second answer. So the last skill we need to learn is how to convert a small number to standard form. So we follow the same rules. We shift our decimal point until we have a number that's between 1 and 10. And as we do that for this number, we have to move our decimal point 6 times. But because we're dealing with a small number, it's going to be a negative integer. So that gives us the answer of 4.8 times 10 to the minus 6.